Hello guys, today we will see how to create character disintegration in Houdini. I have made this cool effect using the vellum particle and smoke simulation, and this slapcom was done by my friend Sahid. I will give that guy channel link in the description. He makes cool compositing tutorial. If you want to learn compositing, you can refer to his channel. So let's dive into Houdini and see how to create this. So here I have already imported the character alembic, and this animation start from 1001 to 1100. First, what we need to do is we need to create an attribute to define on which frame the disintegration should start. Take a add node here. Let's template view our animation. So we need to drag this point around his waist, and it's now our disintegration will start like this from this corner to here. Take a geo node, take a two object merge node, and let's copy this and call out here. And one thing I forgot, that we need to add a attribute wrangle here, and we need to add one attribute called at t frame. T frame is equal to transform frame. We will transform that on frame 1019. This is a pack alembic, so we need to unpack it. Make sure to transform the path attribute, and then we need to convert it. Since it is a polygon soup, we need to convert it as a polygon. Time shift, and we need to freeze this on frame t frame. So our t frame is 1019, so we will freeze that on 1019. Then we will add a polyfill, since we are going to convert this as a VDB. So we need to fill all the holes, and in the fill mode select single polygon, and then take a VDB from polygon node. Since we need some highly detailed mesh, let's keep it around 0.00125, and then take a VDB convert node, convert this as a polygon, and then we need, now if you see, we have highly detailed mesh, but it is a quad mesh. We need a triangular mesh, so we will take a remesh node and we will remesh it. For my PC, I will keep it around 0.0025. If you have a low end PC, then you can adjust it according to your configuration, or else it will get crash. So now we have a nice triangular mesh. Now we will cache this, so it will not calculate again and again. Remesh cache, and it is not a time dependent, so we will cache only the single frame. And then we will store this position as a rest attribute, and then we will take a attribute noise node to deform this character, and in the range we will select 0 center, and we will reduce the amplitude to 0.05, and then we will uh, reduce the element size to 0.2, and we will add some offset to it. So now our character will look like this. Now we will take an attribute noise again, and we will add a color noise here to make scatter value. We need some color to scatter the points for random distribution. Here we will select 0 centered, and then we will select cellular or else Perlin noise. And in the post process we will turn on this minimum and maximum, and then we will take a scatter node and we will turn on density attribute, and here instead of color we will write density. So now our point will get scattered based on the density value, and we need to scatter 300 points, no, 3000 points. We need to edge fracture the mesh, and so to do this we will use a cluster attribute, cluster node. On the second input we will connect our scatter. Now if you click on cluster, so our pieces will something look like this. Since we have stored our original point position on a rest attribute, we can again take a rest node, and then in the mode we can select extract rest. It will go back to its original position. Since this attribute is on a point level, we need to promote this on a primitive level. We will take a attribute promote node, and here we will choose cluster, and in the new class we will select primitive. It will have some issues like here, so to fix this we need to set the promotion method to maximum. We need to add a random color to our mesh based on the cluster attribute. To do that we can use a color node. In the class we will choose primitive, and here in the color type we will choose random from attribute. From here we will choose cluster. We can change the seed if you want, but that is not required. If we add a exploded view, and here in the piece attribute if we choose cluster, so our pieces will look like this. Currently our pieces are not splitted. If you see here, if I point visualize it, we have a one point for both the pieces. We need to split these pieces. So to do that we can take a point split node, and here in the attribute we will choose cluster. Now if you see we have a 2 point for each clusters. We need to convert this as a polygon soup. So we will add a polysoup node. Now we have 2932 polygon soups. Take a distance from geometry node and connect it here. Now if we see the distance attribute, it will be totally purple, and the distance attribute will be also -1. It is happening because we don't have any primitive. So we will take a sphere node here and we will connect it here. Now our distance will look like this. Where is our point? I think there is some problem in the point. My point have been moved little bit far away. I need to keep it around the waist. Now if I see this, my distance will look something like this. As you can see, my elbow area have been turned into yellow. I need to promote this distance attribute to the primitive level. So to do that, again we will take a attribute promote node. In the original name we will select distance, and in the new we will select primitive. Now if I click on this, it will look like this. We need to store the minimum distance and maximum distance on a detail attribute, because we will do some randomization based on that minimum and maximum value. So to do that, we will again take a attribute promote node here, and here we will choose primitive, and here we will choose distance. In the new class we will select detail, and the promotion method will be maximum, and we will turn off this delete original, and we will change the new name, and we will keep distance max. We will duplicate this and connect it here again, and here we will choose, in the promotion method we will choose minimum, and the new name will be our distance minimum. So now if I click on distance maximum, so our distance maximum value will be this, and the minimum will be this. Based on these two value, we will do some randomization on the emission frame. So let's do that now. We have to write a little bit vex code, and I will explain the vex code by here. I will break down the each code so you will have a better understanding. So I will copy paste this code here, and I will keep this run over to primitive. We have to click on this sphere icon, and in the end parameter write 10. If I click on this keyframe, then you can see this, we have some randomization here like this. This will define on how many frame the distinction will be there. So I have kept 10 here, so from 119 to around 1034 our distinction will start and it will get end. If I increase this here, I will show you it. If I take a blast node and then keyframe is equal to $, so there is some viewport error. Now you can see these are our emission frame, and if I want the should stay within 20 frames. So I will keep it to 20, then it will start slowly and it will end till 10:43. So for this I will keep 10 only, because our character is falling too quickly. So let's keep the blast node here only, and then we have to convert this back to polygon. Take a point deform node, and we need to deform these pieces back with our original animation. So on the first one we will connect the convert. On the second input of deform we will connect our time shift, and on the third one we will connect the convert node. So now our emission pieces will look something like this. We need to transfer the velocity from here. So I will take a trail node here and connect it. And in the result, I will choose compute velocity. So now we have some velocity here. Now I will take a attribute transfer node and I will transfer the velocity from here. In the point I will choose velocity. Now you can see our pieces have some initial velocity as well. Now we need to randomize this velocity based on this keyframe attribute. So to do that, first take a attribute wrangle node, and first we need to write few code, and on this second input connect our this object merge of our point, write this code. This code adds some randomization on the source, but it is based on this t frame and some distance minimum and maximum, and we have kept some random value as well. We need to add some call noise to it, so take a point velocity node, and here in the basic we will set it to keep incoming, and in the call noise we will set the scale to 0.44 and the swirl size to 0.1. So now it will have some little impact to it. Now we will take another point velocity node, and in the initialization we will set it to from attribute, and we will keep b, and then we will scale it down to 0.25. So now we will have something like this here, and in the call noise we will add some call noise to it, and we will set the scale to 0.125. We will reduce the pulse duration to 4 and swirl size to 0.05. Now since if you see here, we have one piece here, and then we have some really big pieces. So now we need to do some sub clustering to it, like on one pieces it will have few other small pieces as well, and then in the simulation first the big piece will get detached, and then after few frames the sub pieces will get detached to it automatically. We will going to create something like that. So to do that, what we need to do, we need to take a for each name primitive node, and here instead of name we will choose cluster, since we have a cluster here, not name attribute. And now if I click on begin node, we will see this one piece of cluster. Now we can take a scatter node to fracture sub pieces to it, and we will keep it around 11 pieces. Then we will take a attribute wrangle node, and again we have to write little bit vex, and but the vex is easy. We are just doing some color transmission, and here in the run over type too we have to select primitive. So what here we are doing, first we are taking a near point, and then we are giving some HSV color. HSV stands for hue, saturation and value. First we are converting RGB to HSV, and then we are giving random HSV value, and then we are again converting HSV to RGB. This is what we are doing here as well. Take a primitive split again, that is point split, and here if I click on this, before this our sub cluster borders were same, but after split we have some additional point. So we are done for factoring this. Now we will take a vellum constraint node. Here on the constraint we will choose weld constraint, and we will keep all the parameters default. Then we will take vellum pack node, and we will connect it here, and then on the end we will have something like this. So now we will take a vellum unpack, and we will unpack it. Now we have to set the cloth properties to it. So to do that we will take a vellum configured cloth node, and we will connect it here. We will keep the parameters default only. We will just reduce the edge length to 1.125, and everything is fine. Here we have to do a few things. First we need to, since vellum is a primitive constraint based solver, so we need this keyframe attribute on the constraint as well. Not keyframe, we need this cluster, and I think I missed something here. We should have some subcluster attribute as well. So to do that, we can add one more line here, and it will be si@sub cluster is equal to near pt. So now if I go here and see this, we will have subcluster attribute as well. Yeah. So here we have the subcluster. We need to transfer that cluster and subcluster on the constraint. So take a attribute transfer node, and in the first one connect our constraint, and in the second one connect our geometry. Here we will transfer cluster and subcluster. So it will look something like this, our constraint pieces. We need to again write few codes here, and I will copy paste it here, and then I will set the run over type to primitive. It will set some random keyframe value. Keyframe is our kill frame. As you can see here, we have some randomization of values here, and then we will promote this to point level. K kill frame, and we will promote this on point level. And here again we will take a attribute transfer node here. Here we will transfer keyframe to point. Then we will take attribute transfer node and we will transfer kill frame from constraint to our geometry kill frame. We have set up everything. Now we will take a vellum solver node and we will connect this here and attribute angle to our constraint. But the issue is if we preview this, it won't show anything since on the first frame there is no point and vellum solver don't emit pieces by default. So to do that we need to dive inside the solver and take vellum source node here and connect it to output source, not on the force. We need to connect on source. And here we have to write op input path. We have to put three. We have to go back a 3 level up and then 0. So copy this and paste the same thing on the target as well. And on the constraints subpath we have to put 1 here. And here in the emission type we have to choose each frame. Now if I play this, you can see we will have some pieces which will be getting emitted, but it will cause problem. You can see there is some stretching issue and it is not behaving properly and it is extremely slow. So to fix this, what we can do is we can go on the solver and we can turn off this self collision and we will turn on ground plane as well so the pieces won't fall down. And here in the force we have to set the gravity direction to 0.4 or 5 on the positive, not on the negative. And in the advanced we have to go grain collision and we have to turn off this ignore neighbors with same name or piece, so it won't throw error. If we keep it turn on, then after few frames it will throw an error, so we have to turn off this. And now if I play this, then also it will be slow, but not as slow compared to the last one. You can see our pieces are getting emitted, but the issue is it is not getting break into the sub cluster pieces. So to do that we need to go inside the solver here and we have to take a stop solver node, and here we will keep everything default in the DOP geometry. We will take a attribute angle node here and we will write this code. What this code will do, since we have used weld here and we have a keyframe attribute as well here, so what it will do, we are giving him a condition that if the current frame is greater than keyframe plus 5, then the weld will get break automatically. So this attribute gets read by default in the vellum solver. So now if I play this, you can see our pieces will get break into sub pieces as well. Now you can see here, here the pieces was attached, and then after getting on this frame, our pieces got broken here. So in this way, now all the pieces will get randomly gets break into sub cluster pieces, and it will get smaller. But the issue is, after getting break, we need to scale it mm, down these pieces. So to do that, we will take a vellum constraint property node, and here we have to animate the rest length scale, and we will use vex expression, and we will write this code here. Rest scale is equal to power, and we will use fit range for frame, and we will use k frame and kill frame. Then we will scale it down. So this code will run on a loop. So how it will go, if on frame 20 the rest length scale is 100%, then on frame 21 it will get decreased by 25%, and then again on the 22 frame it will get decreased 25%, and in this way the scale will gradually get decreases. So now if I play this, as you can see here, our the pieces are getting extremely small. As you can see here, we don't see any pieces, but there are points. As you can see, we need to add some advection to it based on the character velocity. So here on the trail node, we will take another connection, and we will add VDV from polygon, and here we will set the voxel size to 125, and in the surface attribute we will choose point v, and in the well name, VDV name, we will keep well, and here in the vector type it will be displacement acceleration velocity, and then we will add a null, and we will give this name as a well. Here dive inside the solver and take pop advect by volume node, and go on the first frame, and we have to paste that null path here, and in the advection type we have to choose update position, and we have to keep the rest of the thing default. Now take a pop drag node to add some drag force to it, and then we need to take pop force, and we will add some noise to it so that it will have some natural movement. We can decrease the pulse length to 0.25 so that it won't move too fast, and we can add some offset to it like this, and we are done with this solver. Now we can take a file cache node and let's cache this out and see how this looks. Uh, so our simulation is done, and see how this looks. So you can see our pieces are getting scaled down, but the pieces are still there. It is just scaled down to its period, and so it is look something like this. Now we need to do same thing for the point as well. So to do that, first take a trail node here, and from this one we'll take a trail node and we will calculate the velocity here, and then on the time shift node we will take an attribute transfer, and we will transfer our this keyframe data, and so our keyframe data stored here. So here on the point primitive we will choose keyframe, and then we will, since this is a static mesh, now we have to again attribute copy to the original animated geometry, and here we will choose keyframe. Now if I choose keyframe, so it will look like this. We need to blast the pieces based on the keyframe. So here I will write keyframe is equal to $f, and here we have to choose delete non-selected, so our this will look like this. And now we have to choose attribute wrangle, take attribute wrangle node and write at 2 is equal to at frame, and at k frame we will do some value remapping here, and we have to put this on primitive level. Now if you see this, previously the keyframe was 1025, but now it will be 16. We are getting -9 from the keyframe value, and now we need to again take a blast node. We will duplicate this one, and here we will simply put greater than $f. Now take a scatter node, and we have to scatter 10,000 point on the global sheet, type $f. So our pieces, our point will get change on every frame. From here point velocity we have to take divide node, and here we have to click on this remove shared edges. Now we can take a primitive property node, and here in the facial we have to keep this close u to open. So now we will have primitive here. We can take resample now, and we can increase the point to 0.0005. So we will have, I think, 0.00 lots of pointer, and then we will take a add node and we will delete the geometry and we will keep only the points. Now we can merge this here, and then we can add point velocity node. We already have velocity here. We will add velocity little bit on y direction, and in the curl noise we will add some curl noise here. The scale will be 0.1. The swirl size will be also too less, so we will have some randomization, small kind of randomization. Now take a attribute wrangle node, and we have to add some density and temperature attribute for color. So now if I click on this and I will go in edit parameter in interface, and then I will choose this to color. Now I will select red here and it will go to black. So our pieces will look, color will look like this. Take pop network node, dive inside it, and let's add a ground plane here. Merge node. Here in the pop object, go in physical tab and reduce the friction to 0. And here on the pop source we have to do few changes. Here in the emission type, choose all points, and here in the geometry source use first context of geometry. On the birth tab we have to reduce the life expectancy to 1.4 and life variance to 0.25. Go in the attribute tab and set the inherit velocity to 0.2, so that our only 20% of the velocity get inherited from the source. Now we can add a pop drag node. Here we will add wind velocity to y direction and set the air resistance to 0.8. Now we can add some noise to it using pop force, and here in the amplitude we can keep it to 2, soul size to 0.25, and you can also play with all these parameters. Here I will keep something like this, and then this will be my big noise and this will be my small noise. I will keep here the soul size to 1.25, 0.125, and the rest will be default. Now if I will play this, my particle will look something like this, but the main thing will happen in on the comp level. Here it will look too dense and weird also, but if I show you my comp render layer, then my particle was also looking like that only, so you don't have to worry about this. So my particle also look something like that only, but after doing some comp, my layer looks like this. So you can manage this on the comp. Here, take a attribute wrangle node and set at p scale is equal to 0.002, and also we can multiply the color based on the age and life, so it will have some impact, something like this. First it will be black and then it will get red. Our pieces will look like this, and let me reduce the point scale. So this will be our pieces. And so on the next tutorial we will see the smoke part and the character part. Make sure to hit the like and subscribe button. On the next one we will learn some cool technique that how to emit smoke from this kind of object. If you like this tutorial, make sure to hit the like and subscribe button. You can get this hip file on my Patreon, so you can support me on Patreon as well. Thank you guys for watching.